Hello, here we are in Chapter 6, finally, Analytic Trigonometry, and our 6.1 topic will be the inverse sine, the cosine, and the tangent functions. So let's begin. So let's do a first little review of the properties of what functions and their inverses. If you recall, now this is just functions in general, not necessarily trigonometric functions, but generalizing the whole rule. If you have f inverse of f of x equals x for every x in the domain of f, and f inverse of x equals x for every x in the domain of the inverse function. So basically, they're saying it's 1 to 1, so it bounces back to the same element when you apply the function and the inverse function to the same element, and that's because it's 1 to 1. And the domain of the function f is the range of the inverse function, and the range of the function is the domain of the f inverse. You recall what inverses do, they switch off. You know, it's if AB works for the function, then BA works for the inverse function. And the graph of f and the graph of f inverse are symmetrical to the line y equals x. But again, that goes to show because the y and x have been switched around. And if a function y equals f of x has an inverse function, the equation of the inverse function x equals f of y. The solution of this equation is y equals f inverse of x. So if you remember, if y equals f of x, then f of y equals x is its inverse. And we write it as f inverse of x. All right, let's now begin with what we really need to talk about, and that's the inverse trig functions. Well, we're going to begin with the inverse sine function. And if there's the wave of a sine graph. Now, if that's the wave of a sine graph, notice the blue portion. Now, the way it is at first, if you take the graph as a whole, it's not 1 to 1 because it fails the horizontal line test. So we have to restrict the domain down enough in order for it to be 1 to 1, and that's why the blue part of the graph is there. It's 1 to 1 on the blue portion. And it takes on all values between -1 to a +1 in between -pi/2 to pi/2. So if we take just that portion of the graph, it's 1 to 1, and so therefore it will have an inverse. So whenever time you apply an inverse function, it has to be between -pi/2 to pi/2. So that's why they restricted x's between -infinity to -infinity to infinity, and y is between -1 to 1, but when you apply the inverse, it's only going to have to be between -pi/2 to +pi/2, and y is between -1 to 1 still. So that last portion is where it's 1 to 1. So what they did was they took that blue snippet of the graph and rewrote it in its own coordinate plane. So between -pi/2 to +pi/2, it's 1 to 1. So therefore, you can apply the inverse of the sine function at that point. Okay? So if we look at y equals the sine inverse of x, it means x equals the sine of y. Okay? Now, that's the blue portion. Alrighty, so where x is between -1 to 1, and y is between -pi/2 to pi/2, because remember, everything gets switched around. So the pink part of the graph is the original sine function, y equals the sine of x. So if you remember what they do with their ordered pairs, everything gets switched. Now on the sine function, they both have 0, 0. So both graphs will go through 0, 0. Now the sine of x has an ordered pair pi/2, 1. Now remember, pi/2 is about 1.57. It's approximately 1.57 pi/2 is. And so if you switch it, it becomes 1, pi/2. And if you notice, that's another point that's in the first quadrant, but it's in blue. Now the pink graph has -pi/2, -1, so switch them around, it's going to be -1, -pi/2. And again, -pi/2 would be about -1.57. So notice though, now we're referring to the blue graph as the sine inverse. Now, if you take the sine inverse of x, that equals y, look what x is giving you. It's between -1 to 1. And y is between -pi/2 to pi/2. So they are switched. The domain of the sine function is the range of the inverse sine function, and conversely. Okay, so that's the sine inverse. Now, let's see, let's go ahead and keep going here. Okay, so find the exact values of an inverse sine function. So find the exact values of sine inverse of 1. Now I want you to notice that when you take the sine of an angle, you get a ratio. But when you're doing the sine inverse, the input is a ratio. That's why you're taking the sine inverse of 1, because 1 is a ratio, not an angle. That's why you don't see a sine inverse of 30 degrees, say. You might see a sine of 30 degrees, because sine's arguments are angles. The output are ratios. And we've had a lot of videos regarding that. But now, when you do a sine inverse, the input are the ratios. And their output will be the angles. So let's look at this. So we seek an angle theta between negative pi over 2 to pi over 2, whose sine equals 1. So sine of theta must be 1. So look down through the chart. So sine of theta equals 1 between negative pi over 2 to pi over 2. If you notice, it's the very last one. So sine of pi over 2 is 1. So therefore, the sine inverse of 1 is pi over 2. So we see that the only angle theta within the inverse interval between negative pi over 2 to pi over 2, whose sine is 1, is pi over 2. Note that the sine of 5 pi over 2 also equals 1, but the sine of 5 pi over 2 lies outside that interval between negative pi over 2 to pi over 2. Okay? So that's what that is saying. And so you can have the sine of many angles giving you 1, as we've seen in the past. But when you take the sine inverse, it only can give you an angle between negative pi over 2 to positive pi over 2. And you've got to understand why that's the case. The reason that's the case is because when you take the sine inverse, it's allowing you to pick an angle between negative pi over 2 to positive pi over 2 only because it is 1 to 1 there. 5 pi over 2 is much farther down the line on that curve down at the bottom. So at 5 pi over 2, it's also 1, but that surpasses the point of where it's 1 to 1 at. It's only that blue interval that's on the graph where it's 1 to 1. So when you're taking a sine inverse of a ratio, you're only allowed an angle between negative pi over 2 to positive pi over 2 over that interval that's in the blue. Okay, that's the only ones you can do because that is where it's 1 to 1. So if you ever take the sine inverse of something, it's got to fall in between there. And think about what you can only take the sine inverse of. Think about what would be the sine inverse of 4. Well, the sine inverse of 4 is a ratio. But that's not allowed on a sine inverse. How come? Because the sine function only its lowest point is negative 1 and its highest point is positive 1. Those are the ratios. So when you apply the sine inverse, you can only take the sine inverse of numbers between negative 1 to positive 1. So 4 would not even be allowed. You're like, well, what if I tried it? It'll give you a domain error is what would happen. All right, let's look at another example here. Finding the exact value of an inverse sine function. So find the exact value of sine inverse of negative 1/2. So we seek the angle theta that's between negative pi over 2 to pi over 2. That's equal to negative 1/2. And there again our table is. So negative 1/2 is number 4 down the bottom from the left. Negative 1, negative square root of 3 over 2, negative square root of 3 over 2, negative 1/2. So the angle is negative pi over 6. So sine inverse of negative 1/2 is pi over 6. Okay? So, what happens if you put it into a calculator? Can you? Yes. You'd have to inverse sine of negative 1/2. Now, if your calculator is in degree mode, the answer would be negative 30 because it's be negative 30 degrees. If you have it in radian mode, you won't get negative pi over 6. You'll get negative pi over 6 equivalent to a decimal. So you wouldn't recognize the negative pi over 6 necessarily it would give you a decimal that may or may not make sense to you. It's kind of taking out negative 3.14 divided by 6. So it's about approximately like a negative 0.5 something. But you may or may not recognize that it's negative pi over 6. So if you're looking for the exact values here, so find the exact values. So you're like, well, could I use the negative 30 degrees if I'm used to if I'm used to degrees as opposed to radians? The answer is yes, unless it tells you to write your answer in degree mode or radian mode. If it says radian mode, you have to put negative pi over 6. If it doesn't specify, negative 30 degrees is actually fine. So if you have any questions regarding this discussion, let me know, and you have a good day.